Bismillahirrahmanirrahim. 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 Acceleration. Acceleration is actually the rate of change of velocity. Change of velocity means acceleration is present. It means when a body is accelerating, then we can say that body is increasing its speed or velocity. It means in simple language, a layman or to a common man, we can describe him about the acceleration as it is the increase of velocity or decrease of velocity. When we say body is accelerating, it means he is increasing or decreasing its velocity. Positive acceleration means increasing its velocity, negative acceleration means decreasing its velocity, and the rate of increase of velocity means increasing velocity per second is the acceleration. If a body is increasing its velocity 5 meter per second, then we say that its acceleration is 5. If the body is increasing its velocity 8 meter per second, then we say that its acceleration is 8. And when we say that acceleration is 6, then it means the body is increasing its velocity at the rate of 6 meter per second per second. The SI unit of the acceleration is meter per second. Per second means meter per second square. And first second is for the meter per second is for the velocity, and the second square is because of the next second, which is in the denominator because of the time. So meter per second means meter per second square is the unit of acceleration. And graphically we can draw it as if the body has a velocity of 2 meter per second, and in the next second if it changes velocity to a 5 meter per second, then it means that it has increased its velocity in 1 second from 2 to 5. It means it has an acceleration of 3 meter per second. And in the next second, if it increases its velocity from 5 to 8, so we can say that in this 1 second, it has increased its velocity from 5 to 8, means 3 meter increase of velocity, 3 meter per second velocity has been increased. So it has an acceleration of 3 meter per second in all seconds, in all the time. It means in the second it has an acceleration of 3 meter per second square, and in the third second it has also an acceleration of 3 meter per second square. So we can say that if the speed of the object increases, and the speed of the object always increases by applying force. Red arrow shows the application of force, and when force is applied on the body, then it means that body increases its speed. And if the force applied is in the reverse direction or in the opposite direction, then speed decreases. As shown in figure, if the force is applied opposite to the direction of motion, then speed decreases. It means it has negative acceleration. Average acceleration. What is average acceleration? If the body is not accelerating or increasing its speed uniformly or equally in equal intervals time, for example, if in the first second body has increased its speed or has a velocity of 3 meter per second, and the next second the velocity of the body is 0.5 meter per second, it means speed slows down, and then it accelerates or it increases its speed to 1 meter per second, and then in the next second its speed is further increased and it is 3.5 meter per second, then we can say that body is not moving with a uniform velocity or same velocity. It is varying its velocity it means it has a changing acceleration. Over here, in this case, we have to take the average acceleration. If someone asks about the acceleration, what is the acceleration of this body, the changing acceleration, then we can not describe a certain acceleration for the overall behavior. We have to take the average acceleration for the whole behavior for the whole time, and we have to take the average acceleration. So in the first second, the increase in speed or the acceleration was 1, and in the next second total change in speed was 5 meter per second. So for the whole 2 seconds, total acceleration or change in velocity was 6. So we have to divide, for taking the average, we have to divide the change in velocity. Total change in velocity is 6 and total time is 2. So total average acceleration is 3 meter per second square. It is important to note, when the sign of the velocity and the acceleration are the same, either positive or negative, then the speed is increasing. When the sign of the velocity and the acceleration are in opposite direction, then the speed decreases. For example, if body is decreasing its speed, then it means that the change in velocity, initially the velocity was 7 meter per second, but if the change in velocity is 2 meter per second and the opposite direction means negative sign, so in the next second the speed of the object will be decreased to 5 meter per second, and if body further decreases its velocity or changes its velocity with a negative value of 2 meter per second, then in the next second the remaining velocity will be 3 meter per second, and this is get by addition of vectors by head and tail rule. You can get it by taking the head and tail rule, as we know that by the tail of the second vector will be joined with the first head of the first vector, and the resultant vector will be from the tail of the first vector to the head of the last one, and which will be equal to 5 meters. Similarly, in the next second you can take the head and tail rule and get the result of 3 meter per second. It means that when the velocity and change in velocity is known as acceleration. So red vector is the velocity and blue vector is the acceleration. If the acceleration and the velocity are in opposite direction, then velocity decreases, and if the velocity and acceleration, means change in velocity, are in same direction, then by head and tail the resultant vector will increase its magnitude, so velocity will increase. What is the variable acceleration? If the body is covering or moving in such a way that in every second it increases speed with different value, then we say that body is moving with variable acceleration. For example, in first second, if we divide the second into half of second and analyze the speed or variation in speed or acceleration, then you can observe that in the first half second the speed is 0.5 meter per second, and in the next half second the variation in speed is 1.5 meter per second. Initially acceleration was in the first half second acceleration is low, and in the next half second acceleration is, but overall change in speed or the acceleration is 2 meter per second for every second. Similarly, in the next second a body has accelerated 1.5 meter per second for the first half, and in the next half second it has accelerated further to 0.6 meter per second. So total change in speed or velocity will be equal to 4 meter per second in 2 seconds. 4 meter in 2 seconds, but the whole behavior in the first 2 seconds is not uniform. In every instant of time, or in these intervals of 0.5 second value, the behavior of the object is having a non-uniform or variable acceleration. What is the instantaneous acceleration? Instantaneous acceleration means a body, the acceleration of a body at certain instant of time, and that instant approaches to very small time of almost zero value as shown in this relationship. For example, if the athlete starts moving and in the second half of a second it has ability to increase its speed for the value of 1.5 meter per second, it means it has the ability to change its speed at that instant of time, or that very small instant from 0.5 second. It has the ability, if it continues its speed with the same phenomena, then in complete 1 second it will increase its speed to the value of 3 meter per second. And we say that the body has acceleration at this instant of value 3 meter per second. So instantaneous acceleration is the limit of the average acceleration as the time interval goes to zero, describes the instantaneous acceleration, or we can get the instantaneous acceleration by using this value. When the instantaneous acceleration are always the same, the acceleration will be uniform. And you can see it in this example. If instantaneous values of acceleration for all the instants is same, in the first 0.5 second acceleration is 1, in the next half second acceleration is 1, and in every instant of time if acceleration is 1, then we say that the acceleration is uniform. So if the change of velocity of the body is equal in equal intervals of time, then, and however the interval may be very small, then we say that the acceleration is uniform acceleration. How? And we can further, if we divide the time interval further into smaller instances, smaller intervals, the behavior of the body remains same. It means in 0.5 second its acceleration was 1, then in 0.25 second its acceleration is 0.5, and the complete 0.5 second acceleration will be equal to 1. So acceleration will be the same for all the instants. Acceleration is the value of change in velocity per second. So over here, for 1 second the behavior of change in velocity is 2. For this case, the change in velocity for complete 1 second is also 2, and for this case, in this situation, for the complete 1 second behavior is same. So we can say that in uniform acceleration the change of velocity or the acceleration remains the same, however the intervals may be very small. If by decreasing the interval, if the behavior does not remain same and different instants are different intervals of time, the body has different acceleration, then we say that this is non-uniform acceleration. In uniform acceleration, the acceleration throughout the movement or throughout the motion of the object in that interval of time, total interval of time, remain same. Thank you for watching the lecture about the acceleration. Now students, we recite Surah Fatiha. Bismillahir Rahmanir Rahim. Alhamdulillahi Rabbil Alameen. Ar-Rahmanir Rahim. Maliki Yawmiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta alayhim. Ghayril maghzubi alayhim waladdallin. All praise for Allah, Lord of the worlds, the most gracious, the most merciful, the master of the day of judgment. You alone we worship, and you alone we ask for help. Guide us to the straight path, the path of those upon whom you have bestowed favor, not of those who incurred your anger, nor of those who are astray. Thank you. Keep watching video lectures about different science subjects on Can College, and please visit the website www.cancollege.com for more information.